Hello, everyone. We've made it to chapter 8. So, in your chapter 8 notes, actually, right at the beginning, there is a summary of both chapter 7 and 8 because it's all on hypothesis testing. Chapter 8 just gives you some new types, but the same 6 steps are going to be used. So, you have your 6 steps here, same as chapter 7. You'll use them again in chapter 8. The main difference is when you need to verify a condition, that'll be a little bit different. So on this summary, you'll have the required conditions for each section, right? So the ones we've already done, chapter 7, those look familiar, but I'll be referring to these when we have to verify conditions. So it's just a one-stop shop for all of the things in the hypothesis test. The other thing is when you calculate a standardized test statistic, that's each section has a different formula. So those formulas are all listed in one place here. Okay. So that's convenient. And then when you're doing step 4, when you have to find a p-value or a critical value, it matters what type of test you're using, a Z or a T. So for each section, I've given you that. Right? What is it? Is this a Z test or a T test as you go through? Okay, and then, finding p-values, right, for a Z or for a T, or if you have to find critical values for a Z or for a T. Okay, so all of those things we've done before. It's just kind of all in one now. Now, the main thing with chapter 8, we're going to get right into it, is we're testing 2 samples now. We're comparing 2 different populations, really. So 8.1 is testing the difference or a comparison of means. Okay, this one's going to be a Z test. Here's your conditions, and then you have this main formula here. Formula's getting a little longer. Now, another element of this section is that we're doing independent samples. So you might have a few questions about what that means. What does it mean for samples to be independent? And so that's our first examples here. Number 1, classify the pair of samples as independent or dependent. So notice in this one, sample 1 is the weight of college students before their year begins. And then sample 2 is the same college students after, okay? So since it's the same students before and after, that would be a type of dependent, let's get a blue here, dependent example, okay? For number 2, though, notice you're comparing males versus females, 2 totally separate samples. So that will be an example of independent. Okay, so usually the dependent is like a before and after, and we'll get to that in 8.4. Independent is just 2 separate, unrelated samples. Okay, so let's try a full hypothesis test of independent samples comparing means. So we need a lot of room because there's 2 different samples. One thing I like to do on these is first pull out all of the numbers and assign variables to them before I even start the steps. So this one we're comparing the braking distance of 2 types of tires, and then a safety engineer conducts 35 braking tests of each type. Okay, so that's an N, right? But we have 2 separate N's. So to denote that, I'm going to do an N sub 1, and then an N sub 2. I mean, both are 35, but sometimes they're different. Where here, the sub 1, let's say that that is for the A's, and the sub 2s are the tire B. Okay, so just to be clear there, what I'm doing. The next sentence, the mean braking distance for type A is 42 feet. Okay, that's a sample mean, and it's for type A. So I'm going to use X bar sub 1. And then assume the population standard deviation, that's a sigma sub 1, is 4.7. Right? Next sentence, the mean braking distance for type B is 45. So sample mean of B, so that's a sub 2, 45. Assume the population standard deviation is 4.3. Okay, and then the only other number is that 10% level of significance, that's alpha. Right? Alpha is 0.1. Okay, so we haven't done any of the steps yet. I'm just writing down the variables. Now let's get into how the steps look. So my step 1 is write down the h sub 0 and h sub a. H sub 0, h sub a. I gotta search for the claim here, right? It says test the claim that the mean braking distances are different for the two types of tires. So different would just be not equal to, so that would be an h sub a. Now here's how it's gonna look. I'm gonna do mu sub 1 not equal to mu sub 2. That's the claim. Notice I'm using mu because I'm making a claim about the population statistics. So I'm saying that the means are not the same based on this sampling. And then the h sub 0, we know would just be equal. Okay, so how are these different than what we've done? Before we would have like mean equal a number, right? Or mean greater than a number. Now you have two separate means and you're comparing them. So there's really no numbers here. But it'll flow the same, and I can still call this a two-tailed test because we have that not equal to symbol for the HA. Okay, there's my step 1. Step 2 is typically a verification. We're just making sure we're allowed to run the test. So I look at my verification conditions list for step 2. Let's go back to that. For 8.1, it's right here. Right? I just got to make sure that the samples are random and independent. The sigmas are known, which we do have that, and either the populations are normally distributed or both sample sizes are at least 30. So I think all of those conditions are met because our n's were 35, and we know the sigmas, and we have random independent. Okay, so check. We've verified the conditions. I'm not going to write anything down, I'm just doing it orally for that. And I'm going right now to step 3. Whoa, where am I going? A little too far. Okay, well, here we are. Okay, now step 3, we got to find that standardized test statistic, the z, in this case. Right, now follow along on that formula. I'll page up a little bit. It's this one right here. That's what I'm doing. Okay. Now, one thing to note about this formula, it looks a little long. It's got subscripts, a bunch of stuff. But this right here, mu1 minus mu2, on these, we're always going to assume that the means are equal, like we have in this one, the HO mu1 equals mu2. So if you subtract two things that are equal, you get 0. Right? And we're always going to do that for this section. So that piece is always going to equal 0. So it's almost like you could just erase it from the formula. And that simplifies things a little bit more. So our formula is just going to be the x bars subtracted up top, and then that square root thing on the bottom. And that's it. Okay, so what I'm going to do first then is subtract on top x sub 1 minus x sub 2, x bar sub 1 minus x bar sub 2. And so that's the top, that's 42 minus 45. And then in the denominator, we have that big square root piece. And notice up top is sigma squared, sigma sub 1 squared, 4.7 squared, divided by n sub 1, just 35. And then within the square root, I've got the other one, 4.3 squared, That's the sigma sub 2 squared divided by n sub 2, which turns out to also be 35. Okay, so that's plugging in the numbers to the formula, and that'll give you my z-score. When you're plugging this in, yeah, there's a lot going on. You could probably do it all at once in your calculator. Again, put parentheses around that numerator to make sure the order of operations work. And then try it out, just make sure we're getting the same answer so that you're putting it into your calculator right. But this one, you should get about negative 2.79. So let's just squeeze that right here, negative 2.79. Okay. And that's that formula, right? So again, what we did there is we just ignored that and we did this. Okay, that piece. All right. So that looks pretty clean. That's really what's new in this section. Steps 4 and 5 are going to be really the same as what we've done. So if you're comfortable finding critical values or p-values or whatever method you're doing, you're going to be good here. So for this one, let's just do the critical value method, or that would be the rejection region method. Okay, so for that step, I've got to go and find my critical values for a two-tailed test with alpha equal to 0.1. If it's a critical value method and it's a standard common alpha, which it is, 10%, you can just look that up in these notes. I'll point you to the right direction for this one. It's that table right there. Okay. Critical values for a t test, z test, right? So we're doing 0.1, two-tail, there it is, plus or minus 1.645. Okay. Those are called critical values. So that would be a z sub 0, plus or minus 1.645. All right. Next, I got to decide, okay, am I going to reject h sub 0 or fail to reject it? And it helps if you draw a little picture. You don't have to, but it's a little more visual that way. Right? What we're doing is putting the critical values where the shaded regions are. And then I'm trying to decide, okay, is that z-score that we found in the shaded region or not? So if I plot that negative 2.79, it's going to be well to the left of negative 1.6. Right? That's the negative 2.79. So if that's the case, if it's in the shaded region, it's reject h sub 0. Okay. Finally, we need the conclusion. Coming up with your conclusion is the same that we've done before. Use that little conclusion chart, page 1 of this handout. H sub A is the claim. We rejected H sub O. So if you rejected H sub O, you can support H sub A, right? There is sufficient evidence to support this claim. Okay. And then that would be it. Now I did that one with the critical value method. We could have used the p-value method. That would involve, getting the table out, the yellow table, looking up that p-value using that z equal negative 2.79, and then comparing it to alpha. You can try it that way too if you want. Should come up with that same conclusion though. Okay, that's probably all the time we have for this video. I'll stop there. That's the end of page 4, and we'll pick up where we left off in the next segment. Okay, thanks. Talk later. Bye.